Hello and welcome all my grade 11 students to today's session for end of term questions exam coverage. We are covering today selected questions for sequence and series. This video is part 2 of the exam coverage for grade 11 elite. So a gentle reminder to like, share and subscribe to the channel if you're watching the video finding it useful. Also, if you have not watched part 1 of the exam coverage, I would highly recommend that you watch that one before you watch this one. I will put the link in the description box and you can see the part 1 from the top right corner of this video. So let's get started. So in today's session, we are going to use from sequence and series the sigma notation for solving the equations, and our learning objective would be to use sigma notation to represent and calculate sum of series. So here 57 to 62, a lot of questions are given. I will help you how to write the sigma series. Now pay attention and see how the sigma notation works. Let me write it here for you. So when I say sigma notation, what should come to your mind is the summation. So summation means you are adding something. So from 1 generally it starts and it goes up to k. So it's a finite sum that you are calculating for an. So it is like a1 plus a2 till ak, because it is given till the upper bound k. Here this is called, let me highlight with a different color. This is called the lower bound of the summation. This is called the upper bound of summation. An is the nth term and this is the finite sum. So you see here some finite sum is given. How many terms? 1, 2, 3, 4, 5, 6, 7, 8. So you know the upper bound is going to be 8. What is the lower bound? It is already given to you. So it starts from n equal to 1. Now you have to look for a pattern. You have to see what is the pattern in this series. -2, -1, 0, so on. So if you start from 1, then the first term is 1 minus of -3. I can write like this: 1 minus 3. The next term is 2 minus 3. The next term is 3 minus 3, 0, and so on. So there is a pattern that you see here. So the pattern is the nth term, which is n minus 3. So you can write this in summation notation or sigma notation as summation n equal to 1 to 8 n minus 3. So that's how 57 will be solved. Then 58. Here you see 1 by 20, you see fractions. So the nth term would have fraction. The lower bound is 4. How many terms? 1, 2, 3, 4, 5, 6. So 6. 1, 2, 3, 4, 5, 6. 6 terms are given. So you start from 4 and you end till 9. That's how you count the number of terms. Now, look at the first term, 1 by 20. Look at the next term, 1 by 25, 1 by 30, 1 by 35. Do you notice a pattern? Yes, all are multiples of 5. So can I write this as 5 multiplied with 4, 5 multiplied with 5, 5 multiplied with 6, 5 multiplied with 7, and so on. So the formula is 1 over 5 to the power n. It starts from the lower bound n, it goes till the upper bound 9. In a similar way, let's do the next question. The first term is 8. The next term is 27. The next term is 64. The next term is 1000. And if you see, these are all perfect cubes. So the formula for the finite sum would be n cube, and it is starting from the lower bound 2 till, what is this? This is 10 cube. So that means n will go from 2 to 10. So that's how you write the sigma notation. Similarly, for the other terms also, I hope you've understood the pattern, how the sigma notation works. Okay, next question on sequence and series is from the topic of arithmetic sequences. So here you have to find the nth term and the arithmetic means of the arithmetic sequences. So find the specified value of the arithmetic sequence with the given characteristics. Now, before we solve this question, I would like to remind you from your book, page 121 to 22, this concept is given nicely, and it talks about finding the nth term of an arithmetic sequence. So if you have an arithmetic sequence, that means a sequence which is differing by the same number, there is a common difference, then an is equal to a1 plus n minus 1d. This is the formula that is going to help you, where a1 is the first term, d is the common difference, n is the nth term or the number which is denoting, and this is used to find the nth term. So this formula will help you to solve all the questions. Now I will solve 18, 19, 20 and 21 for you, and in a similar way you will solve 22, 23, 24 and 25. They are exactly similar, just the numbers are different for the questions. So let's do these questions in the next slide. I want you to notice when I'm solving these questions how just using one formula will give you the answers of all the questions. Okay, so let's start with 18th. So I will write first the formula an equal to a1 plus n minus 1d. Now which term is given to you? 14th term. That means a14 is given to you. That means the value of n is 14. What is the first term? You don't know. Keep it like that. N is 14, so 14 minus 1. D is also given to you. So D is 9. So just simplify a to the power 14, put the value, substitute is 85. A1 plus 13 multiplied with 9. So this gives you A1 as 85 minus 117. So your A1 is minus 32. So that's your answer, the first term. Okay, let's do answer 19 now. It is again very easy. Now see here, observe the first term is given but the common difference is not given. So remember, for the sequence minus 24, minus 31, minus 38 and so on, common difference or your D. How do you get? You take any one term. For example, I take this term and subtract the previous term. So minus 31 minus of minus 24. Minus minus becomes positive and you get it as minus 7. So that's your solution for question 19. Okay, let's do 20 here followed by 21 here. Okay, so for 20, an is a1 plus n minus 1d. I told you I'm going to use the same formula. So an is given to you as 14. I am just substituting the value. The first term is given to you as 36. N is not given, that's what you need to find, and D is 5. So what I have done is just pure substitution of 1, 2, 3, three values in the formula. And now we are going to simplify it. So 5 would distribute, and this is going to be, I'm moving 36 on the other side. So 14 plus 36 is 5n minus 5 or 5n. Now I move the 5 also here. So just do the addition. So this is 19 plus 36, which is 55, equal to 5n. Divides both sides by 5. So how much is your n? This in this colors, and n is 11. So n value is 11. Last question, 21. A1 is given, D is given, you have to find A12. So An equal to A1 plus n minus 1D, same formula. Now you need to find 12th term, that means value of n is 12. First term is 47, n is 12, so I'm putting the value. D is also given minus 5, so you can very well simplify. This comes out to be 47 plus 11 times minus 5, which is 47 minus 55, which is minus 8. So the 12th term is minus 8. So with that, we have completed all the questions. I hope you've understood how you solve questions on arithmetic sequence using the nth term formula, and you can try now questions 22, 23, 24, 25 yourselves. So these are the final answers. Do let me know in the comment section, have you got these questions correctly? And we have just done similar type of questions. So remember, the formula is important and your method is important, how you are solving it. Next, we have some word problems on the sum of n terms of an arithmetic series, and these are taken from your math book. The concept is given on page 125, 126, so please refer to it. The formula that I'm going to be using is Sn equal to n by 2, 2a plus n minus 1d. Now, I want you to recall Sn is the sum of n terms of an arithmetic series. So this is the formula. N is the number of term. A is the first term. D is the common difference. N is the nth term. Okay. So now you see here. Let's read the word problem. I want you to understand the pattern which is given here. So a crew is tilling a hotel lobby with a trapezoidal mosaic pattern. The shorter base of the trapezoid begins with a row of 8 tiles. So you don't have to be confused by the difficult words which are mentioned. Just look at the numbers because you are going to use these numbers for solving the question. Now each row has 2 additional tiles. This is an important thing. 2 additional tiles means your common difference would be 2. First term a or a1 is going to be 8, and until how many terms? Until 20th row. So n is going to be 20. So you have got the value of a, d and n. So if you have a, d and n, you can calculate the sum. Now determine the number of tiles needed to create the mosaic pattern. So let's substitute the values of a1, d and n here. So n is 20, so 20 divided by 2, 2 times 8 plus 20 minus 1 times d is 2. So let's calculate. So this is 10 times 16 plus 19 multiplied by 2, which is 16 plus 38, which is 10 times 54. So this is 540 tiles. So that's the correct answer. In a similar way, you will solve the next question. I will give you a hint and then you will check your answer. A snow mobiling competitor travels 12 feet in the first second of the race. So this is the value of A. Okay, if the competition travels 1.5 additional feet each subsequent second, so this is the value of D. How many feet did the competitor travel in 64 seconds? So 64 seconds is given to you. So A is done, D is done. This is the value of N. So you put these values and get your sum. I will be doing question 56 for you. This is an important question just like 54. So let me just explain you the question and then we are going to solve it in the next slide. Lana organized a charity walk. In the first year, the walk generated this one. So that means this is the value of A. She next hopes to increase the amount by this month each year. So this is D, $900 for the next several years. If her goal is met, in how many years will the walk have generated a total of at least this much? Now this is the sum. Sum is already given. What is not given? N. So N you have to find. So we will use the same formula, but we will use the formula to find the value of N. So let's do it in the next slide. So let's write formula first. Sn equal to n by 2, 2a plus n minus 1d. We are solving here answer 56. So what is given to you? Sn is given $65,000. N you don't know, so I'm keeping n as it is. The value of A was given in the question as 3,000. So I'm going to put N we don't know, and D is given to you as 900. So let's just simplify. We are going to use a distributive property here to open the bracket. So this is n by 2, 6000 plus 900 and minus 900, and here you have 65,000. So now this is n by 2. Combine these two. 6000 minus 900, which will be 5100, plus 900n is equal to 65,000. We are going to simplify and we are going to cross multiply. So 65,000 multiplied with 2 is 5100 n plus 900 n square. Now what you have got? Quadratic equation in n. We are going to simplify it a little bit more. Let me use the calculator for the calculation. So here the equation that you are getting is 900 n square plus 51 n this, and along with it you have minus 13000 equal to this. Now let's see if this equation can be divisible by 900. So we'll check that. So you can simply remove 100 from here, so it will become this much. Now you solve for the value of n, and your n will come out to be 10 or more years. So that's how you solve. And now let's see all the answers together. Question 54, 55 and 56. We use the same formula, n by 2 multiplied with 2a plus n minus 1b. So learn the formula and use it well in your exams. Next we have from sequence and series, the learning objective: find sums of n terms of geometric series and sum of infinite geometric series. This question is on infinite geometric series, as you can see. So we are going to use the key concept of sum of infinite geometric series. So I'm writing here sum of an infinite geometric series. And if that question is coming to your mind, how do you know that this is a question on infinite geometric series? Then one thing is the keyword given in the question. Second thing is this dot dot dot. It is going on forever. Even in the sigma notation of summation, n is from 1 to infinity. So this infinity tells you that we are having an infinite sum. So you are going to use the formula S equal to A1, which is the first term, divided by 1 minus R, for this is true for absolute value of R less than 1. So that means this sum S, which is given by A1 to the power 1 minus R, this important formula is valid for the common ratio less than 1. I hope you know R is the common ratio of the geometric series and A1 is the first term. Then S is denoting the sum. So this formula we are going to use, and we are going to first check. We'll be doing 3 questions here: 56, 57 and one more 60 in solving the question. So look here carefully. The first term is given. The first term is given, and here also this is the sigma notation. Let me write here. This is the sigma notation. Sigma notation denotes the summation. So it is running from n equal to 1 to infinity. So it's an infinite series, but you can get the first term by putting n equal to 1. So you will be getting the first term from here. Okay, or this can be written as in the notation of summation also, like summation. I can write this, just compare with the sigma notation: n equal to 1 to infinity a1 r to the power n minus 1. So you know your a1 is going to be 6, your r is going to be negative 0.4. Okay, Now the absolute value has to be less than 1. This is a condition you have to check, because sometimes in the question that is not happening, and in that case the sum will not exist. You cannot use this formula. So let's solve question 56, 57, 60 in the next slide. Okay, so let's solve question 56. Here the series is starting from 1 by 20, then 1 by 40, then 1 by 80, and so on. It's an infinite series. So what is the first term? 1 by 20. Let's calculate the value of R, common ratio. So common ratio is the ratio of any two terms. So this term, if I take 1 by 40, then its preceding term 1 by 20. So we divide it. So it is 1 by 40 multiplied with 20 equal to 1 by 2. So you have got the value of A1, you've got the value of R. This is your R. So once you have A1 and R, what is the formula for sum? I showed you in the last slide, A1 over 1 minus R. So this is going to be 1 by 20 over 1 minus 1 by 2, which is 1 by 20 divided by 1 by 2, which is equal to 1 by 20 multiplied by 2, or 1 by 10. So what is the answer for this question? Answer 56. Final answer is, the sum is 1 over 10. Let's do 57 now. Now for 57, first you have to calculate the value of R, which is the common ratio. So if I take the common ratio, for example, I take 4 by 7 and then I divide it with 2 by 7. So this is going to be 4 by 7 multiplied with 7 by 2, which is 2. Now absolute value of R is 2, which is more than 1. This is not allowed. For the sum to exist for the infinite series, for the formula S equal to A1 over 1 minus R, this is valid if absolute value is less than 1. So we can say the sum does not exist. Okay. Last question that I'm going to do for you from this slide is this one. So we had the summation notation n equal to 1 to infinity A1 r to the power n minus 1, which is given to be in the question summation n equal to 1 to infinity A1 negative 0.4 to the power n minus 1. So we will use the formula of S equal to A1 over 1 minus R. Now directly your A1 is 6 and your R is negative 0.4. So directly we can just substitute, and this comes out to be 6 over 1 plus 0.4. If you're wondering how this negative changed to positive, remember the common difference R is negative here. So negative of negative is positive. So this is 6 divided by 1.4. Remove the decimal, this becomes 60. Simplify, divide by 2. So 30 over 7. So the sum here, final answer is 30 over 7 for the sigma series. So this is how you solve the question, and now you can check all your answers. For 56 it is 1 by 10, for 57 does not exist, for 60 it is 30 by 7, and you will now try the remaining questions yourself. I'm sure using the correct formula and doing the correct steps you will get the correct answers, inshallah. Next we have questions on mathematical induction. So we are going to be solving these questions using the principle of mathematical induction. So this is from lesson 3-4 from your math book. If you want to refer to it, it is given nicely on page 143. So it is from there that I'm using the principle of mathematical induction for explaining you these questions. So first I'm going to write here the principle so that you are reminded, and then we are going to see question 13 to 16 how we solve it using principle of mathematical induction. So let Pn be a statement. So this is the usual given statement that's given to you about positive integer n. Okay, so this Pn is coming from the integer. Then if we have to show that this Pn is true for all positive integers n, then there are two conditions. If and only if. What is the condition? The first condition, P1 is true. You have to check that. Okay. So just check that in the question. We are going to do that very shortly in the questions that we are going to solve. And second, for every positive integer k, if pk is true, k is an integer, okay, then pk plus 1 is true. Very, very important. So let me explain you a little bit. So this principle of mathematical induction is basically the principle that a conjecture can be proven true if you can show that something works for the first case, that is your base case or your anchor case. So this case is P1. Okay, so we are going to check whether P1 is true or not. Once it is true, we can move to the second step and assume that it works for any particular case. That is the inductive hypothesis that you take, that for every positive integer k, pk is true. You assume that, you make that assumption, and then you show that it works for the next case. Next means just after pk, that is pk plus 1. That's the inductive step. So these steps are going to be followed for solving the questions. And we begin with question number 13 now. So here I have provided you the detailed solution. Let's just understand what is happening. So you are given a statement. So I told you Pn is the given statement and it is given true for all integers, positive integers n. So 9 to the power n minus 1. That's your Pn. So let Pn be the statement 9n minus 1 is divisible by 8. So you are given a number 8 and you are being given that Pn is the statement that shows that it is divisible by 8. You have to prove each conjecture is true for all positive integers n. So we are going to use the principle of mathematical induction. We are going to first check for P1. So what will be P1? If Pn is 9 to the power n minus 1, then P1 means you are putting value of n1. It will be 9 minus 1, which is 8. So it is divisible by 8. That means P1 is true. Every number is divisible by itself, remember. So P1 is true because 8 is definitely divisible by 8 itself. So now we will make the assumption. We are moving to step 2, where we make the assumption that okay, Pk is true where k is a positive integer. And if Pk is true, we have to show that Pk plus 1, the next one, the inductive step, is also true. Okay, now if you are taking the assumption that pk is true, then we can say pk minus 1 is some multiple of 8 because it is divisible by 8 for some integer r, and this we have to now check whether pk plus 1 is divisible by 8 or not. If that is true, we will say by the principle of mathematical induction, we are done and we have reached to the proof of the conjecture. Okay, so 9k minus 1 equal to this. This is the assumption that pk is true. Now you can write 9k as, you just move the 1 on the other side, 8r plus 1. Now you multiply both sides by 9. And if that question is coming to your mind that why I am doing so, then your answer is because I want something which is k to the power, which is something to the power k plus 1. So in order to make this k plus 1, I need another 9. So that's why I'm multiplying with 9 here, and I cannot do it on one side only. It will create an imbalance in the equation. So I have to multiply that 9 on both sides of the equation. So when I do that, the left side reduces to 9k plus 1, which is what I want because I'm checking on the divisibility of k plus 1. And the right side, you just do the distributive, multiply, it is 72r plus 9. Now, this 9k plus 1, from both sides, I'm now subtracting minus 1. Why I'm doing that? Because I need the value of this thing, 9k plus 1 minus 1, because I need to check whether it is a factor of 8 or not, whether it can be written in the form 8 to the power r for some integer r or not. So that's what we are trying to do. So when we subtract 1 from both sides, what you get is this thing. And definitely 8 is common now. 72 and 8, you can take an 8 outside and it can be written as 8 multiplied with 9r plus 1. So you have got, for r any integer, you have got 9k plus 1 minus 1 can be written as a factor of 8. So if r is an integer, 9 multiplied with r plus 1 is also an integer, and 8 multiplied with 9r plus 1 is divisible by 8. This thing is divisible by 8. Therefore, we can say the left side is also divisible by 8. That means 9k plus 1 minus 1 is divisible by 8, and because Pn is now true for n equal to 1 and Pk implies Pk plus 1, therefore by the principle of mathematical induction we are very confident that 9n minus 1 is also divisible by 8 for all positive integers. So we used these steps of principle of mathematical induction and a little bit of algebra to prove the divisibility. So that's how you do the question. Okay, next question is very similar to the last question, so I'm going to go a little fast here. We are using the same principle of mathematical induction. The only difference is in the statement. So the statement Pn is given as the statement that 6 to the power n plus 4 is divisible by 5. So we are going to assume that we are going to check first for P1. Is P1 true? So I put n equal to 1. So 6 to the power 1 plus 4 is divisible by 5. Very true, because it is equal to 10, which is divisible by 5. So P1 is true. That's we have checked. Now let's make an assumption that Pk is true, where k is a positive integer. So if Pk is true, I can write 6 to the power k plus 4 is equal to 5r for some integer r, and we have to check whether k plus 1 is true or not. So let's use this thing which is for k to prove for k plus 1. So we'll do the same thing like we did in the last question. We'll get the value of 6 to the power k and we'll move the 4 on the other side. It becomes minus, and then we multiply both sides by 6. Why we do that? Because we need 6 to the power k plus 1, and that is what we get here once we multiply with 6 on both sides. So this thing on distribution becomes 30r minus 24, and now we add 4 on both sides because we need plus 4 here. From this is the thing that we are proving. So we add 4 on both sides. So when we do that, 6k plus 1 plus 4, that's what we need, comes out to be equal to 30r minus 20. Now what is common in 30 and 20? A 5, definitely. So you take the 5, which is the common factor outside, and write the inside part as 6r minus 4. Now you started with r being an integer and you got another integer 6r minus 4, and 5 times 6r minus 4 is definitely divisible by 5 because it has a factor of 5 with it. Therefore we have got the conclusion that 6k plus 1 plus 4 is divisible by 5, and because Pn is true for n equal to 1 and Pk implies Pk plus 1, again by the principle of mathematical induction, Pn is true for all values 2, 3, 4, 5 and so on, and by the principle of mathematical induction we get our answer that 6n plus 4 is divisible by 5 for all positive integers n. So now I hope after doing 2 questions on principle of mathematical induction, you have understood the pattern which is coming, and the same pattern and the same method with the different numbers is being applied to different questions. So again, for question 15, Pn is the statement that 2 to the power 3n minus 1 is divisible by 7. So you check for P1, it is true. You assume for Pk it is true and you take this value. Then you check it for k plus 1, do a little bit of algebra like we have done in the previous one, and by the principle of mathematical induction you get your answer. So very similar method, just go through it and you will be getting the correct answer. In a similar way, you can prove using mathematical induction the Pn for this statement, question 16, that it is divisible by 3. Take P1 as 5 minus 2, which is 3. So divisible by 3 for sure. Assume pk is true, that means this thing is true, and prove for k plus 1. So you do the similar way. The only thing is here algebra is a little different, so let me explain it to you. So 5k, 5 to the power k minus 2 to the power k is equal to 3r. You move the 2k on the other side, you get this. You multiply both sides with 5. Why do you do that? Because you need 5 to the power k plus 1. So you got 5 to the power k plus 1, and on the right side you write 5 as 2 plus 3, just a little bit of algebra which is happening. So multiply, use distributive property, this comes out to be 2k plus 1 plus 3 times this plus 15r. Now, you need to subtract on both sides 2k minus 1 because we are looking at this factor. And I hope you are able to understand after you see this subtraction that this term is cancelled, and that is the reason why I have written 5 as 2 plus 3 and not 5 here on the right side. Okay, now you subtract 2k plus 1, so this comes out to be 3 times 2k plus 15r, so you can take a 3 outside common, and this again is an integer. So because r and k were integers, 2 to the power k plus 5r is also an integer, and 3 multiplied with it is divisible by 3. Therefore this whole thing is also divisible by 3, and Pn is true for n equal to 1, and Pk implies Pk plus 1, so Pn is true for all values of n, and by the principle of mathematical induction we have got our answer, we've got our proof that 5 to the power n minus 2 to the power n is divisible by 3 for all positive integers n. Next we have the question on binomial theorem. So use the binomial theorem to write and find the coefficients of the specified terms in the binomial expansion. This is given nicely in your math book on page 152. So I want you to refer there in case you want to see how questions are solved. I will be solving one question, important one for you, question 22 in the next screen. And let me just remind you, when we talk about binomial coefficient, we are referring to NCR used by the formula n factorial over n minus r factorial times r factorial. So let's see what is the binomial theorem, how it is used in finding the coefficients, and solve question 22. In a similar way, I would want you to solve the remaining questions, and this is going to be the answer that we will get. Okay, so this question is from your lesson of binomial theorem. So we have to use the key concept of binomial theorem. So first I'm going to write the formula for finding the binomial coefficients of a plus b to the power n using the binomial theorem. Just to remind you, and this concept is given very nicely in your book on page 152. So if you want to refer to that once more, you may do that. So the theorem says the binomial coefficient of the term a n minus r multiplied with b to the power r, this term in the binomial expansion of a plus b to the power n is given by the formula. So this is a formula you have to remember, NCR. So we are using combination, we are selecting n out of r out of n outcomes. So n minus r factorial times r factorial. Okay, so this is the main key concept that is going to help you for solving the question. So let's do it now. So here you are given 2x plus 3y to the power n, and you have to find the binomial coefficient corresponding to the term which has x to the power 6, y to the power 3. So I want you to first understand that the first term here refers to 2x and the second term refers to 3y. So your value of a is 2x, your value of b is 3y, and what is the value of n? N is 9. Now you want to compare this term now. Let me write a n minus r b to the power r with x to the power 6, y to the power 3. So what is your value of r? Very easy to understand. Your r is 3, your n minus r is 6, and that's well defined because n is 9. So n minus r, that is your 9 minus 3, would give you 6. So well defined, yes. So n and r also you have got from the question itself. So these are some important things you need to figure out before you start solving the question. So let's do it now. Okay, so we need the binomial coefficient of the term having this thing, and we are going to use the binomial theorem. So I'm going to use this formula NCR now. I have my n as 9, I have my I have my r as 3, so NC3. This is what we are going to calculate. So let's do it. So n factorial over n minus 3 factorial times 3 factorial. So this is going to give you, let's simplify, 6 factorial multiplied with 3 factorial. Now 9 factorial can be opened in this way, and we will open it only till 6 factorial because eventually the 6 factorial in the denominator is going to cancel it. So here I have 9 multiplied with 8 multiplied with 7 over 3 multiplied with 2. So let's simplify it a little bit. Let's cancel the common terms. So 3 2s are 6. 3 will go here with 3, here with 2. So this is going to give you, this is going to give you 4. So it is 3 multiplied with 4 multiplied with 7. So this is 84 if you simplify. Now you have got the binomial coefficient. Now you need to find the final answer. So for final answer, one extra step is involved. What is that step? It is 9c3 a to the power 6 y to the power 3. Now how much was your first term a? Let's substitute. 9c3 a is, we have got it here, 2x, b is 3y. So we are just putting value 2x to the power 6 and 3y to the power 3. Now 9c3 already we have got as 84. So what else is coming in the coefficient? 2 to the power 6, x to the power 6, 3 to the power 3, y to the power 3. I'm just opening up and trying to simplify. So this is a huge number which is going to come as 84 multiplied with 2 to the power 6 is going to give you 64. 3 to the power 3 is going to give you 27, and remaining is x to the power 6, y to the power 3, and that's exactly what we want, x to the power 6, y to the power 3. So we need the coefficient of this. That means we need this big number, and when you are going to multiply all of it using your calculator, it will come out to be 145,152. So that's the binomial coefficient. A pretty long one, but an important question. In a similar way, you can solve the questions which are given in the end of term exam. So this is the concept of binomial theorem, and it helps you to find the binomial coefficient. So that brings us to the end of part 2 video, which was specifically on sequence and series. It was a long video, but a must-watch video. I hope you have reached to the end of the video and you have watched throughout all the questions, how we are solving it. It has taken a lot of time and effort for me, and I'm making these videos specially for all my grade 11 students during my National Day break. So I hope you are benefiting from this. You are sharing it with your friends who will also benefit from the same, and you are preparing well for your coming exams. So with that, I wish you best of luck for your exams. Inshallah, you will all do well. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.